Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of probability, and if I talk about the question that is given to us here from this topic, the question tells us to consider an experiment where you are tossing a coin repeatedly until the two outcomes of consecutive tosses are same. And the question is asking if the probability of a random toss resulting in head is one third, then we have to find the idea where the probability that the experiment stops with head. So basically probability that your experiment or whatever outcomes you are getting should end with head. And you are been told here that you are going to toss the coin unless you get the outcomes of two consecutive tosses same. Either that means that you get both heads or both tails, then you stop your experiment. Until then you do continue your experiment, but the probability is asking that you need to find the probability that the outcomes which you are having should end with heads, means at the end you should have both heads. That is the idea asked to us. And if I talk about the answer choices that we have been given here, the options are one third, 5 over 21, 4 over 21, 2 over 7. So these are the four answer choices that we have been given here. We need to find the correct answer choice for this question that is given to us here. Let's see how to solve this question further. Before starting off with the solution for this question, I would first like to tell you that please do subscribe to my channel and support the channel as well, because it takes lots of efforts in making these videos for you on everyday basis, and it is free for you to subscribe to my channel, but also motivates me to put up better content and try to make the solutions as easy as possible. So let's see how we'll solve this question further and find the probability of the question which is asked to us here. So first of all, if I see the question, it says that the probability of head is one third. Now, when the probability of head is one third, I understand the probability of getting a tail in this case is two thirds. And since probability of heads and probability of tails are not equal to each other, I understand basically this is not an unbiased coin. This is a biased coin where you have double chances of getting a tail compared to getting a head. So this is a biased coin here. Now the experiment which was given to us, it involves tossing this coin repeatedly until you obtain two identical outcomes in a row. So when you obtain two identical outcomes, it means either both would be heads or both would be tails. So we are interested in the case where we have been asked to find the probability where it ends with heads. So we need to find the case where I have two repeated heads here. So my probability or my experiment will stop at that point. Now for this, you will have two different scenarios where it ends with heads. Let's consider that. So first scenario I can have is it begins with a head and ends with two heads. So it can be begins with the heads and ends with heads. So you get two heads. Begins with a head, then you get tails. So you continue your experiment because you don't have two identical outcomes, and then you get both heads. So you stop here. Then you can have HT again. So you keep continuing your experiment because you don't have two identical outcomes again, and then you get both heads again. So it ends with two heads. It can be like this. So it basically begins with heads and ends with heads. So this is the idea. Begins with heads and ends with heads. And you stop your experiment when you get two identical outcomes. So the first scenario is this. The second scenario I can think of here is I begin with a tail, then I get two identical heads and I stop the experiment. So I begin with a tail, I get again a head, but then again I get a tail, again I get a head and a head. So I stop it here. I can again begin with a tail, head, tail again, and then two heads. So I stop the experiment here. So this is how you get your second scenario. So these are the two scenarios. First is beginning with a head and ending with a head. So you stop the experiment when it ends with head. And the second scenario begins with the tails and ends with a head. So that is your other scenario. So let's see what will the probability be for the outcomes in the two scenarios that we have discussed already. So talking about the first scenario, the first case where it begins with a head and ends with heads as well. So two heads and then you can stop the experiment. So basically that means if I talk about sequences beginning with heads here. Let's see what I'll get here. So first thing I can see here is I can have simplest sequence where first I can understand it can be the probability where both are heads. So I stop the experiment here only, beginning with a head. So to get a head, I know the probabilities are 1/3 and 1/3, which basically gives me 1/9. The second case I can have is beginning with a head, then a tail, then again two heads. So you get from here 1/3, 2/3, 1/3, and 1/3. So what you understand is for the two heads at the end, you always have a probability of 1/9. And then if you are starting with a head and then you will have a tail because you then continue the experiment, you get for this individual outcome where you have heads and the tails as 2/9. Next, if I see again beginning with a head, but then I get a tail, so I have to continue the experiment. Again a head, again a tail, so I have to still continue the experiment because no two outcomes are identical. Then I have a double head again, so it ends with head. So in this case, I will again have 1/3 into 2/3 into again 1/3 into 2/3 into 1/3 into 1/3. So what I understand is there is a pattern of number that is being developed, 2/9 square into 1/9. Then for the next scenario when you will have heads, tails, heads, tails, heads, tails, and then two heads. In that case, again, if you check out, you will have 2/9 cubed into 1/9. So if I see everywhere I have 1/9 common and 2/9 is increasing by one power in every outcome. So what I have is if I want to find the total probability of this entire scenario, I'll add all of these outcomes. So I'll have infinite number of possibilities here. So probability of beginning with head and ending with two heads. I have 1/9 plus 2/9 into 1/9 plus 2/9 square into 1/9 plus 2/9 cube into 1/9 and so on till infinite terms you are adding. And when you're adding all of these infinite terms, 1/9 is common. You get 1 plus 2/9 plus 2/9 squared plus 2/9 cubed, and this continues till infinity. So what I understand is to get every next term, I have to multiply my previous term with 2/9. So the ratio that is present for the sequence of outcomes is a constant sequence. So I have a constant ratio, and that basically means it's a question of sum of an infinite geometric progression. And for sum of an infinite geometric progression, I know the sum would become a over 1 minus r. So a, I know it is 1, that is first term. 1 minus r, I know in this case is 2/9. So I get from here 1 over 7/9, and that gives me 9/7. So if I see this 1/9 into 9/7, 9 and 9 gets cancelled, you get 1/7. So for the first scenario, I get the total probability turning 1/7, and that basically becomes my answer for the first case that is there. Let's talk about the second case. Now, if I talk about the second case, case 2. So case 2, I again begin with the tail and end my outcomes with double heads. So once I end with double heads, I get the probability which is required. So first scenario can be one tail and two heads. So for a tail, I know it is 2/3, and for heads, I know 1/3 into 1/3. So I stop the experiment because I get two identical outcomes and I get 2/3 into 1/9. Further, if I check, I get tails, then heads. So I don't stop my experiment, I continue it. Again, I get a tail, and then I get both heads. So I stop it here. So you get 2/3 into 1/3 into 2/3 into 1/3 into 1/3. So you get 2/3 into 2/9 into 1/9. So you get 2/3 and 1/9 as it is. The extra outcome or extra term that you're getting is 2/9s. Then you have terms, sorry, tails, tails again, and then two heads again. So you again have 2/3, 1/3, 2/3, 1/3, 2/3, 1/3 into 1/3. So from here I get 2/3. This becomes 2/9, 2/9. So 2/9 squared, and then you have 1/9. So you have this outcomes. Now, if I see this repetition continues till infinite terms, till you get two identical outcomes. So if I add all of the optional probabilities for the entire case here, so probability of beginning with a tail and ending with double heads gives me 2 over 3 into 1 over 9 plus 2 over 3 into 2 over 9 into 1 over 9 plus 2 over 3 into 2 over 9 squared into 1 over 9 and so on. So I get from here 2/3 and 1 over 9 common. And then what are the terms left? 1 plus 2 over 9 plus 2 over 9 squared plus 2 over 9 cubed. This continues till infinity. So I get from here 2/3 or 2 over 27 into this. Basically again becomes a infinite geometric progression, and I get from this a over 1 minus r. So 1 over 1 minus 2 over 9. So I get from here 2 over 27 into 1 over 7 over 9. So 9 ones, 9 threes. I get from here 2 over 21. So for the second scenario, I get 2 over 21. And if I want to find the answer which is asked for us to figure out in the question, it says probability of ending with both heads. And I add the two scenarios here. One is 2 over 21. The other was 1 over 7. If I make the denominator same, multiplying both sides with 3, I get 3 plus 2, 5 over 21. And if I talk about the answer choices that matches here for the question that is given to us for this 5 over 21, it matches with option B. So B becomes a correct answer for the question that is given to us here. I hope you have understood how to solve this type of questions which deals with the ideas of using the concepts of probability. I'll see you again tomorrow with some other question from some other topic, and we are going to continue our series of questions on JEE Advanced. So stay tuned for more videos to roll out. Also, if you are enjoying these videos that we are doing on everyday basis, please do like the videos as well and do subscribe to my channel and share this channel with your friends also who are involved in the preparation of questions on JEE, so they can also take the benefit from these questions which we are solving on everyday basis. Thank you.